So with fractions, what did you do with fractions? Who did they did with fractions? You? Yeah, what'd you do with the fractions? You did it with fractions. Okay. Okay.
Did anybody multiply to get rid of the fractions? Okay.
That's another good strategy to use too.
Because I think that's possible. What?
I said I know how to do it, but I don't know how to do it.
We're going to look at an example like that on Monday, where we multiply to get rid of all the fractions and make everything whole numbers too.
Yeah, because you could have done that here as well, and that would have really helped you. Anybody know what number you would multiply to get rid of all these fractions in this way?
No.
4 would still leave a fraction over there. Okay, go ahead.
You'll multiply it by like flip it and multiply.
Okay, well that's one way to get the idea, but which one would you multiply by here? Wrong. Well, if you multiply by 2 over here, that's going to get rid of this fraction, but it's not going to get rid of this one. Same thing, whoever said 4 earlier, that'll get rid of this fraction, but it won't get rid of this one. Well, that's what we were just doing here. So here's what happens. If we do that, let's say we do 1/2 b plus 4. Okay, if we multiply everything in here by 2, watch what happens. It will cancel 2 times 1/2. That will cancel this here, so you will get b. And 2 times 4 is 8. But look what happens on this side. You would have 2 times 1 over 8b plus 88. And when you multiply 2 in here, you get 2 over 8, which is 1 over 4 times b. So you would still have a fraction over here. Okay? So that helps you out on this side, but you still have the fraction on this side. Any other ideas of what fraction you can do there? How would you get rid of that?
If 2 doesn't work and 4 doesn't work, what's a little bigger than both of those that might work?
Zoe, try again. Not 6. Not 5 either. We're just guessing now. 8. Your common denominator, if you added them together, would have been 8 anyways, right? So if we multiply by 8, watch what happens. Okay, so here on this side, both sides are going to multiply by 8. 8 times 1/2 b, that's 8 over 2. 8 over 2 is 4, right? So this would become 4b. And then 8 times 88, what's that on your calculator? You guys know. 740. Okay. That's a lot easier to work with than all those decimals, isn't it? That's another possibility, another way that you could do that. And like you said on Monday, we'll be going over a lot of those so you can see and come up with a plan on how to identify that and then move along from that. But here, if I just subtracted b from both sides, 3b plus 32 is equal to 704. If I subtract 32 on both sides, 3b equal to what, 6, so that's 6, so what am I, 32, it's 672, right? And then if you divide by 3, what do you get now? 224 again, doesn't it? Okay, so there you go. Same answer either way. Sometimes there's more than one way to do this. Okay. Yes? Yes, you may. Okay. Anybody have trouble with any of the other ones? 7 was
But today we're going to go through it, and I kind of outlined exactly what you need to do. So our objective is to now solve equations where we have variables on both sides. So we've been building up to this. In 2-2, we solved it where we just had a variable on one side. In 2-3, we solved it where we had a variable on one side, but we had to do two operations to solve. Now we have variables on both sides, and we need to do multiple operations to solve. So yesterday you heard me talk about drawing a river. I like to treat my equal sign as my river, so whatever I do to the left side, I have to do to the right. So I also, one of my hints is that I try to move the variable that's going to keep my numbers positive. So like in this case, if I move 4, it's going to make my x's negative. But if I move the 3x, it'll make my x's positive when I move them to the other side. So I always try to look for the variable that's going to keep my variable positive when I move it. So step 1, I like to draw in my river. So draw in your river. So you guys, I put the steps on the left. I want you to do your work on the right like I am. So you're going to rewrite out the equation, draw in your equal sign river, and follow me along. So what do you think I'm going to do next, based on what we just said, Zoe? Perfect. I'm going to subtract 3x from both sides. So what that's going to look like is negative 3x from both sides. So on the left side, my variables are gone. And then on the right side, I get x. So I'm going to combine my like terms where I have 2 equals x minus 1. Any thoughts on what I do next? Zoe? Perfect. We're going to add 1 to both sides so that I get all the constants on the left and the variables on the right. And then 2 plus 1 is 3. So I get 3 equals x. And again, we talk a lot about checking these. How am I going to check this? What are you going to do, Nevaeh? Perfect. I'm going to put a 3 in everywhere I add an x. So it's 3 times 3 plus 2 equals 4 times 3 minus 1. So 3 times 3 is 9. 9 plus 2 is 11. And then 4 times 3 is 12. 12 minus 1 is also 11. So we're super duper happy that the answer I got checks when we plug it back in. Okay, solve 8y minus 9 equals negative 3y plus 2. So what would I do first, Dominique? Perfect. I'm going to add 3y to 8y. So I like to draw in my river, and then I'm going to add 3y to both sides. So 8 plus 3 is what, Nick? Good, so I have 11y minus 9 equals 2. Luke, what am I going to do next? Perfect, I'm going to add 9 to both sides. So that gives me, what, Madison? That's okay. 11y equals 11. Abby, what do I do next?
You would divide 11 and 11.
Perfect. Yeah. Yeah, it would be 1. Good. So you divide both sides by 11, and we get y equals 1. And then I always like to check, so I just take 1, plug it back in. 8 times 1 is 8 8 minus 9 is negative 1. And 3 times 1, well, negative 3 times 1 is negative 3. Negative 3 plus 2 is also negative 1. So we are super happy. We get negative 1 equals negative 1. Okay? I don't know why my numbers are missing. Take a second and determine what is the value of x if 3 minus 4x equals 18. That's so weird.
Very strange.
Because when I click for the answer to pop,
Uh-huh.
they pop up.
Huh.
It's on their papers though, so I typed it out. So once you think you know if it's 1, 2, 3, or 4, you can go ahead and hold up a 1, 2, 3, or 4. Thanks Dominique, thanks Madison, thanks Nevaeh, thanks Luke, thanks Zoe.
Abby's got one up.
Up, thanks Abby, couldn't see you. Okay, Logan's got up a number, good. Luke, you're good. It's just waiting on Landon and Nick. Okay, Nick. Landon, what'd you get? Okay, no problem. I just wanted to make sure you knew I was asking.
You try to check these, please? Run the check on it, see what's up.
Perfect. Yep, so we'd add 4x to both sides. So you get 3 equals 18 plus 5x. Subtract 18 from both sides. And you get negative 15. And then that's equal to 5x. And all of us divided that by 5. And got that we had negative 3 for our answer. So we got negative 3 for our answer. Okay? Solve 4 equals 7x minus 3x. Now, this one looks a little different than the last one. What's different about example 3 from some of the other ones? Zoe, what do you think? Yeah, the variables are on the same side. So when the variables are on the same side, what am I going to do to start this problem, Dominique?
You have to subtract 7 minus 3, you will get
Yeah, so what do I get?
4x.
Perfect. Yeah, negative 4x, right? So does anybody know what it's called when Dominique took 7x minus 3x on the same side and made 4x? What do you think, Zoe? Combine like terms. Excellent. That was that math word I was looking for. So when we group together on the same side, that's calling combine like terms. So awesome. We noticed exactly what I wanted us to notice. The variables were on the same side. So we're going to combine like terms, and we're going to get exactly what Dominique said, which is that 4 equals 4x. What do I do next, Nevaeh? Yep, you got it. So we're going to divide both sides by 4. So we get 4 divided by 4, which is 1, and equal to x. So what do you think I'm going to have you do? Check it. I heard somebody say it. So we get 4 equals 7 times 1 minus 3 times 1, which checks. Okay? So we kind of have two options we could go about doing for this problem. Both would be okay. Anybody want to give me a suggestion for what they would do when they saw this? What do you think, Dominique?
You have to multiply negative 7 for x and minus 3 is going to be negative 7x and it was
Yeah. So you wanted to distribute your 7 into the problem, which is exactly what I did as well. So I took that negative 7 and I distributed it in. We could have actually divided by negative 7 to start as well, but I think that's the less commonly shows action. So I said there were two choices. I assumed most of our choices would be to distribute. Then we're going to subtract the 21. So this one stinks a little bit more than some of the others because my variable is negative. So you just got to make sure you tag along that negative each time we write it down. So I have negative 7x equals negative 28. And what do we know about dividing a negative by a negative? It becomes a positive. So when I divide both sides by negative 7, I get x equals positive 4. Make sure we're writing these down, guys. Okay, last one. Now we have to double distribute. You got to double distribute. So go ahead, take a second and double distribute and solve for x. And then when you think you got it, you can hold up a number. Thank you, Dominique. And I'll let you know when I see it. Okay, Abby, got you, Nick, got you, Madison. Okay, Zoe. Okay, Luke. Okay, Logan. Okay. So we're kind of all over the place, so I actually want to do this with you. We distribute to get 3x plus 12 equals 2x minus 2. And then I would move my 2x. So I'm going to subtract it from both sides. Can I make my blue river? I can. So that gives me x plus 12 equals negative 2. How many of us lost that negative? And then you subtract 12 from both sides. And we get x equals negative 14. So we're not dividing here, we're subtracting. So I think a couple of us said 14. The reason it's negative is because you're subtracting, not dividing. So if you had 1, you got it right. So that kind of summarizes where we are for today. Your homework is that next page labeled homework. For the first part, I did all the steps for you. I want you to tell me what we're doing in those steps. So that's kind of like what I was doing over here to the left of the problems. I was writing down what we were doing for each of these steps. So that's kind of what I want you to do for the first 2 homework questions. And then for the rest of them, you're just solving.